In this module, we will discuss a few important functions on IP software that I think will be useful in your journey as a log interpreter. These are related to bad hole flags, making a proper layout for log plots, and finally log exports. Bad hole flags are required where the wellbore stability has been an issue. In that case, multiple washouts may be observed through higher than usual caliper log readings. These can happen when drilling takes place through overpressured zones or weak and unconsolidated sediments. These can also happen when directional drilling takes place in directions with unfavorable stress conditions. Other causes may be using lower than required mud weight, which can cause wellbore breakouts. The major concern with large washouts and large breakouts is that the petrophysical calculations can be erroneous. Well logging companies generally provide corrected logs for these zones, but errors can still be there. So, if you flag these zones, those flags can help you better visualize the condition of the wellbore and tell you about the level of confidence you should have in your petrophysical calculations. In these bad hole conditions, the log readings such as density, neutron porosity, microresistivity, and NMR are unreliable because these logs read close to the wellbore. On the other hand, gamma ray and far field resistivity would be okay since much of their readings come from a larger volume of the rock and away from the wellbore respectively. Let's take a look at a simple method to make a bad hole flag in IP. For this procedure, we will use the IP calculator and we will use well A this time, whose caliper log I modified for demonstration purpose. So the formula is the difference between caliper and bit size. And we will create a new set which is bad hole flag. So the curve name, we can call it caliper bit size difference. Units are in inches. Let's select this output set. So we will leave the if row empty, and we will also not fill any top or bottom depths because we want to do it for the entire well. So let's run. So now it created this bit size caliper difference in inches. Next, now is the step to create the flag. So we will say if the caliper bit size difference is greater than 2 inches, then put a flag, and the value of the flag is 1. and there is no units, and let's call this flag. Okay. So 1 means flag, otherwise there is no flag. So run. So now you see the flag has been created there. So if you want to display this in the log column, then let's open the well. So file, file, load plot format, and you see that there is nothing here in this well. So we will go back to well B where we saved plot 1. We will choose that format and open. Okay. So now we have chosen the correct plot format, or we could have made a new plot format. Okay. So yeah. So we have this gamma ray caliper and bit size already displayed here. Now we would like to display the flag. Okay. So let's for some time switch off the gamma ray. So you see in black is the bit size and in blue is the caliper. So I just artificially change these values for demonstration purpose. So if you want to display the flag, you can drag it here. So let's try to put the flag on this side of the well, okay, of the log panel. So what we will do is, since we want to display it on the right side, so we will change the scale, let's say from 20 to 0. So we will just basically reverse the scale. Okay, so now those flags are displayed on this side, and if you want to color it, then we can go to shading, and then we will go from the curve to 0 on the right side, correct? So we will choose the curve name, which is your flag, and the right side is a fixed value of 0. Left side, see, left side of the shading is curve and the right side is the fixed value of 0. And let's choose red color. Okay, so now see the flags are displayed right there. These are the bad hole areas, and if you don't want any overlap between this curve and that curve, then you can probably change to change the caliper to maybe 20. See, now there is no overlap. So this is how you display the bad hole flag. Again, please note that in the actual well, this blue line goes directly downwards, following the same profile as before. Okay, so these are artificially created for demonstration. One more thing is you can put it in this gamma ray track, or you can put it in an independent track like these bad holes, or you can also try, you can even put it in this NP-ROB track here, because these logs are highly affected by bad holes. Once you have completed the petrophysical interpretations, you need to present your results to the stakeholders. For that, you need to put the raw and calculated logs in a proper layout. I'm sure by now you know what buttons to click on IP to get there, but on account of completeness, I will show you an example of a proper log plot format. Let us use well B because we performed most of the calculations in this well. So this was the previous log plot for well B, So let's modify this. So we have the tops, which is good. And then keep the depth panel like that. Let's also select the TVD. Next, I think we can keep this towards the end. Next, we can display the well plan. Select the well diagram and the well plan. Okay. So we can see the perforation locations and the packers, as well as the casing and liner. Next, we can display it like this, except if you want these two lines of bit size and caliper a little bit to the right, so that it does not overlap with gamma rays, then maybe you can change their scale. So this will apply to both caliper and bit size. So now they are to the right and they do not have much overlap with gamma rays, so that's good. Next, you have the medium and deep resistivity. So that's fine. You could also display the true resistivity, but it's fine. We can just display these two. And since they are taking up much space on both sides, so let's change the left scale a little bit. So now it's shifted towards the left. Rho B and phi crossover plot is fine. This is in the limestone scale. If you wanted, you could put it in the sandstone scale. We will leave it in the limestone scale. Let's make a new track and let's put the slownesses dt. So basically what we are doing is displaying the raw data actually here, and then we will show the calculated data. So let's change this scale, because you see they are not visible here. So let's change from 240 to 40. Okay. And one more thing we can do is, if you want these lines a bit thick, then you can change the width of the lines. So now they are thicker, looking better. Next, we can put the porosities. So we can keep the neutron density porosity and the effective porosity. And let's remove this red one. Okay. Yeah, so this is looking good. Main thing is to make it look good in the zones of interest, okay? Don't go too far up and try to adjust something here, because your zones of interest are right here. So now we have the porosity sorted out, and always display the core values, because that's the standard procedure. Then we can also display the permeability. Okay, and if you want, also display the core data on permeability. So the scale you can adjust from 0.1 to 1000, that's fine. And let's say you have to keep the same scale for the core as well. You cannot keep them in different scales no matter which log it is. Okay? And put them in log. Okay, so okay, so now the core data is displayed. If you want to make them a little bit bigger, okay, so this is the core data. And if you want to make it look better, if there is too much blue on the screen, then make it brown. If you want, make it to see, you have to play with it a little bit and see which one you like. So this is fine. uh, Next will be the saturation. So we have our saturation already there, so let's shade it a little bit. So this side is mainly brine, so we can shade it using blue. It goes from 0 up to the curve name, which is your SWRG. And shading type is this aqua color. Aqua means water, so now it's all watery there. Okay, and we have the core data displayed. Next you can put the pay flags. So pay flag, you can make it from 0 to 1 and shade it from the fixed value of 0 up to the curve name. And you can shade it in green or red, because we had it earlier displayed in red. I can display in red, but you can use a different color again based on your preference. So these are our pay flags. This is where you should make the perforations to extract the gas or a little bit of oil. Next we can display the lithology track. So lithology is already here. If you wanted, really, you can take the V shale, because generally it's good to display the core data. So they are there, and you want to play with the color a little bit to make sure it's visible. About red, and make it a little bigger. Yeah, so the core data for the clay volume is now visible. Make sure it's all of these things are visible, so that if you cover it like that, then nobody knows what is this, even though the expert geologist would know that this is limestone. But for a layman, he needs to see the legend. Okay, so make sure all the legends are visible. Next we can remove one of the rock types we had before. So this was based on both effective porosity and V shale, so we'll keep it, and we will remove this one. Okay. make sure that things are visible. Let's change this to 2000 to make the whole log visible. Okay, now the full data is visible, and okay, so you can make this thinner because you don't need so much flag space. Basically, you have to start adjusting from the right side. That will help. It will make it easy for you. Okay, so now it looks better. So this is the final layout, and if you wanted, if we really had a bad hole, then we could put our bad hole flag on this one, this column, or this column, or we could make an independent flag, but since we have a good hole, we didn't need that. And finally, there are fancier ways to display this plot. Your employer can have a different preference for the layout, or you can have a different preference, but whatever is the established procedure, please follow that. Okay, so now you can save this as save plot format, and you can call it final plot. Save it. Once you have completed the petrophysical calculations, you need to deliver your process logs to the geologist, who will import that in tools such as Petrel. In Petrel, the geologist will have already imported the raw well logs and placed the wells in correct locations and at correct depths within the oil or gas field. He will use the petrophysical outputs you provide and populate the wells with those properties. He will then distribute the petrophysical properties from the well location into the entire reservoir to populate the geologic grid cells using established basin modeling techniques. Therefore, you need to know how to export the process logs for delivery to the geologist. We will go to in out, export data, and we will export the files as LAS. So here our well is already selected. Let us select also the other well. So we have displayed the second well, but let us only select well B. Here you can use this button to select or unselect. This is the well name. These are the top and bottom depths for each well, and these are the steps. These are the default steps. You can also change this one. For example, instead of taking 0.1 at each 0.1 increment, you can take it to 0.2 increment if you want a smaller output file. The reference curve is always the MD, which is measured depth. The file name will be LAS out. This is for well 2 because we named that well as well 2, and this is for well 1. Then if we want to export, so look at these, there is available curves and there is selected curves. So whatever is available will be displayed here, and whatever you want to export should be first pulled here and then exported. Okay, so let's look at how to do that. For example, we can go to, for this So we want it for well B, correct? Okay. So for well B, let us choose the flags that we created, and suppose you only want the pay flag, and then press control reservoir flag and keep the control pressed, and let's say you want pay H and you want the reservoir cumulative height or thickness, then you can do that, and you have to click on this button to get it here. Okay. And if you want, for example, you can also drag a log. For example, you select here and then drag it. That's also what you can do. Okay. And suppose you want to export all the logs in this flags set, then simply you have to just click this button and it will export everything that is in there. If you want to remove one of these buttons, one of these curves, you just have to just select it and then remove the selected curves using this button. If you want to remove all of them, okay, one thing is if you want to remove another one, then you have to again select it and then remove it. The control button doesn't work here, so you have to select one by one and remove it. And if you want to remove all of them, you simply click on this one. All of them are removed. Okay, so let's put some of them back. Let's say. Okay, you can also change the order. Let's see. Okay, you can also change the order here by simply selecting that and using these buttons, up and down buttons. Okay. One thing here is that the LAS version allows you to choose which LAS version you want, version 2 or version 3. Version 2 is the original LAS standard, and version 3 LAS files include a wide variety of data and require last 3 data importers. So to be safe, if you are not sure about where these logs will be imported again, just use the LAS2 version. Okay, what do these buttons mean here on the left? Here you can just browse and choose the logs, choose the place where you want to save these logs. Okay. One thing, okay, these are the null values that will be outputted, and you can select the decimal places for accuracy and I mean precision. And you see, one thing you can do here is, instead, if you don't want like this LAS out name, you can use anything like export here and then apply. You see, the names have changed here. So we will just use LAS out because it shows you what type of file is being outputted. Okay. One thing you can do here is use these buttons. If you want to select all curves in all wells, let's see. Then you can click this one, but I don't like it. Correct? We don't want all the all the logs because much of that is useless. We need to only export the logs that we want. So I'll just clear all of that. Okay. So let's choose our calculated ones because we saved most of our results there. and let's choose, so let's choose all of them. Okay, and in the flags folder we can choose the pay thickness, pay cumulative thickness and reservoir cumulative thickness, and so it should be down there. Okay. One more thing you can do here that's very convenient is if you don't want the whole well data, then you can go here, get depths from zones, and you can select the tops, and suppose you only want something from upper Hugen to lower Hugen bottom, you can select that. Even though I like to include one formation above and one formation below the actual producing formation, but for now let's choose the producing formation itself. Okay, so see the depths will change in this well. Okay, so just take a look there. Okay, when I press OK, see it took those depths. And suppose we select both wells and we again do this, let's say all wells. If I selected all wells, let's see, so see if you select both of them, if the zones are not there, then you will not get those options there. Okay. Those zones must be there in both wells. Uh, one more thing is if you have selected both wells, see if you have selected both wells, and if this curve set is not in both wells, then it will display nothing. Okay, but if you choose the default curve set, then you see these logs, these raw logs are common to both wells, therefore they are being displayed here. And see, they are colorless correct right now. So if I just unselect that and select that, then they have now green color, which means these logs are there in that well. So let's export only the logs from this well, this one. Okay. Okay. So now it is writing to the folder for that well. One more thing is in this in out you had other options for exporting the data, for example ASCII. So this, what does just one second. So you know this LAS files that we had before, those LAS files are similar to the ASCII files, and their full name is log ASCII standard, LAS. Okay. So you also have an option to export as ASCII files. You will get the same options. So just select this well, and let's say select the calculated one, and it will be written as ASCII out. Let's select the depth again. select point 2. Okay, and you also had another option, which was a DLIS. There are many different options to export them. DLIS is called Digital Log Interchange Standard. Okay, they contain binary data structures which are not directly interpretable by humans without specialized software or tools. But if there is a tool that can read the DLIS file, then you can export that. So in this one, we have the DLIS out. Okay, so let's choose the tops and same. Okay, so okay, so now let's look at the folder in which they are saved. So we'll go to desktop. This is the, well, so we have the output, ASCII, LAS, and TVD survey. So this is the LAS file output. Okay, so it looks exactly like a real raw data file, and you have all the information there about the well, and then you have all the curve information that we calculated. These are all our calculated curves, as you can recognize from it, from the name. And these are the files, and you can see that the output increment is every 0.2 feet, every 0.2 meter. Sorry, because we chose that number. So this is a smaller file. You see, it's only in that huge information, so it's a much smaller file. Okay. How about this ASCII? You see, ASCII file looks very similar to this. These numbers are the same, except that the top here doesn't look similar to LAS file. So much of this curve information is not there, and the well information is not there that much. Okay, so that's the difference. But you can read both of them. At the depths, you can read the values, correct? And finally, let's open this DLIS, and this is the DLIS file. You cannot read anything. You don't understand anything, because this is a binary data structure which can only be read by specialized software or tools.